Starting with the great name of Allah, who is the most merciful and the most beneficent. This is Rajacharan from Electrical Engineering Department, Sakaraibi University. I am here to give a presentation on our final year project, that is remotely controlled agriculture pesticide spraying robot. This project is made by me and my group mate Hazrat Hilal under the supervision of Dr. Suresh Kumar. We are very thankful to our supervisor for his help and guidance throughout this project. So the table of contents that I am going to discuss are project overview, in which I will tell you about our aims and objective, then literature review, then our proposed design and its features, then the methodology and implementation, the method that we use to implement our project, then the project flow of our project, then the robot parts, then hardware implementation, then development of Android application, and then hardware demonstration, then future plans and references. So agriculture is the most important factor for the survival of people. Almost 70% of the population depends on agriculture. For increase the productivity of crops and high yields of product, what farmers do, they wear heavy sprayer on their shoulders and go to fields for spraying the pesticide manually. There are so many disadvantages of this manual pesticide spraying, like it may can contact with skin and can trigger skin cancer and asthma illnesses. Most of the birds and animals are affected due to this manual pesticide. So in this agriculture, robotic technology can be used for spraying pesticide. So what we are doing, we are introduce a robotic system that can be used for spraying pesticide in agriculture. Introduce this technology will not only save the life of farmer, but it also provides some final beneficiation to the farmers. Like it will reduce the waste of pesticide, that the pesticide waste into the air. So this robotic technology can be controlled through an Android application. So the farmer can remotely control this robot to spray the pesticide in the agriculture. So the aims and objective of our projects are, so our aim is to design a remotely controlled agriculture spraying pesticide robot that can move in irregular surface. So we know that the fields are not flat. Those fields are irregular. So we are designing a robot that can move in irregular surfaces. So in order to achieve the aim, our objectives are to develop six-wheel structure robot that can move in different terrains, to develop remote control system using Android application, and a manipulator that contains a spray nozzle, and we use camera to see the live streaming through the robot. We can see the fields where we want to spray the pesticide. So this is the literature review that we gone through for making our project. So the very first one is agriculture pesticide spraying robot system controlled using Android application. In this paper we find that the robot is can be controlled by Android application. This paper is published in 2022. So in this project we find that a robot can easily be controlled through Android application. And the other paper that we found is autonomous pesticide spraying robot for use in a greenhouse. This is autonomous robot, and in this project we find that the robot is moving on a railway track. So this is an autonomous robot. This cannot be controlled by remotely. And the other paper that we find that is modeling and simulation studies on the mobile robot with self-leveling chassis. In this paper we find that there is a robot which named as wheel-leg robot. This robot can walk, also can move. Means this robot can move in flat terrain surfaces and can move in flat surfaces. So this is our proposed design, that we will develop a six-wheel structure of robot. So this is the six-wheel structure robot. This is our proposed design, and its features are that this robot can easily be controlled through a mobile application, and this robot can sustain the overload of bucket that we put on that for pesticide spraying. And the robot can easily move and spray pesticide. Integrated camera to see the live streaming of the fields where we are spraying pesticide, and robot can move in irregular surface. That is our main aim. So here is the methodology and implementation, that how what method we choose to implement our project. So as our project is consist of two parts, one is hardware part and the second one is software part. So hardware part consists of cost-effective elements that we are using in our project, and software part is consist of an Android application that we will develop. So the complete system is controlled and monitored through an Android application from a remote place. It means that the farmer can spray pesticide to the fields by keeping some distance from the fields. So there will be operation of relay for pesticide spraying robot. We will use DC pump for spraying the pesticide, and this DC pump will be controlled by a relay. So here is the method that we choose, what we will do in step by step to complete our project. So in the start, we will design the robots part in the SolidWorks. Then we will print the parts using 3D printer. Then we interface the hardware, and then we develop the Android application. And then we will interface this application to the hardware so that we can control the hardware with Android application. So this is the project flow of our project. So here is the software part on left side. Here is the when we start the Android application. What we have to do, we have to provide our IP address to control the movement of the robot. This is our software part. And in hardware part, we are seeing that in the start, when we start our hardware, we will show the live streaming on the Android app. So for controlling the pesticide spraying, so initially the relay will be normally open. So if we want to spray the pesticide, we will on the relay, and relay will get normally closed. So the pump will be start. So we can control the movement of spray nozzle that is on the robot. So by the servo motor movement, by moving the left and right servo motor, we can spray the pesticide from left and right to the fields. Here is the complete hardware methodology of our project. So this is the robot part designing that we design in using SolidWorks. Here is on left side, here is boogie part that we design in the SolidWorks that is used in our robot. And in middle there is rocker part, and in right side there is plate stand on which we will put our plate to make the robot stable. And these are the other parts, like this is plate on which we will place our components. And the other one is spray nozzle that we use to spray the pesticide. It will be connected to the manipulator to spray the pesticide. So this is how we print our design part. In previous slide, I show you the design parts, and this is the printing of these parts. We printed these parts using 3D printer. So after printing this part, we get the printed parts. You are showing that these are the printed parts that we printed using 3D printer. So here is the hardware implementation of our project. Then in this hardware implementation, we used ESP32 microcontroller, H-bridge motor driver, servo motor, DC gear motor, wheels, ESP32 cam, FTDI programmer, water bucket, DC to DC buck converter, DC pump, single channel 5-volt relay module, and a battery of 12 volts. So this is the connection that we used. First of all, we start from very basics. So here is the connection of servo motor. That's the servo motor is connected to ESP32 microcontroller, and here is the servo motor for left and right rotation. So when we connect this servo motor with ESP32 microcontroller, we get this result that servo motor is moving left and right. For controlling the direction or rotation of the servo motor, we provide signal to servo motor of different degrees. Like here you are shown that when we give the input degrees to 10 degrees, the servo motor will move 9.5 degrees. Here is theta 1 is input degree that we are providing, and theta 2 output degree that the servo motor rotate. If we give 10 degrees input, the servo motor rotate up to 9.5 degrees. If we are giving 20 degrees input, the servo motor is rotating 9.7 degrees. So this is maybe because of that we put a manipulator over the servo motor. So that's why for weight of that manipulator, it may be there is some quantity missing in the rotation of servo motor. So here is the other connection of pump. I already said you that we used single channel relay module to control the pump. Because we are operating pump on 12 volt, so 12 volt can be controlled through relay module. So we connect relay module with ESP32 and for controlling of pump. So this is the result of pump, that when we switched off the relay, the pump is off, and then we switched on the relay, the pump get on, and we are ready to spray the pesticide. So here is the ESP32 cam that we used in our project to see the live streaming of the fields, so that we can pesticide the pest on the position where we want. So here is the connection of ESP32 cam. So here are the results that when we upload the code to this FTDI programmer, so we get an random IP address, and we put this IP address to Google URL, and we find this this live streaming on that particular IP address. So here we are using ESP32 cam to see the live streaming. So our next part was development of Android application. So we make an Android application using MIT parameter. So MIT parameter is very easy to use. By using drag and drop, you can make beautiful apps on this MIT app inventor. So we also use this MIT app inventor to develop our Android application. And start, I already tell you that our software part will be of an Android application. So its flow chart is here given on right side. So in this start, we will provide an IP address to control the movement of the robot. So here is the result of that Android application. That here you are seeing that the live streaming is shown on the app. We actually provide the IP address that is provided by the code of ESP32 in this Android app to see the live streaming. And here are some buttons for the controlling of servo motor. Here is left and right for controlling the servo motor, and for controlling of the pump, here is on and off. And the other buttons are to controlling the robot, like forward, backward, left and right, and stop. So, and here is the IP address that we will communicate with ESP32 microcontroller to get control the components that we are interfaced with the ESP32 microcontroller. So here is some demonstration of our hardware, that in this Android app, the robot is controlled and the live streaming is shown on this Android app. You can see that we are controlling our robot by using this Android application. So here is DC pump and robot control. After controlling the robot and all the components like servo motor and DC pump, we get these results, that when we here on x-axis there is time when button is pressed from Android app, and on y-axis there is time when action is taken. So if we give input on 10 seconds, so the robot forward will take an action after 0.3 seconds. Means it means that there is delay of 0.3 seconds to get the robot move forward. Similarly, when we give signal of pump on at 15 seconds, so the pump will be on after 0.2 seconds. It means that in controlling of the DC pump and robot control, there is some delay. This may be due to traffic on the web page, or maybe to respond the ESP32 controller, that because we are using web page, the Android app is controlling is communicating with web page, and web page is communicating with ESP32 controller. So because of that, there may be some delay. So here is 0.3 second delay in robot control, and there is 0.2 delay in the control of DC pump. So here is another graph of robot speed, that on what speed our robot is moving. So in the start, for testing that, in the start we start with no load testing. When we move the robot without any load, like there is no load of bucket over it, so it will move with the speed of 1 meter per second. It cover 1 meter per second. When we start the increasing the load, when we put a load of 200 grams, the speed of the motor decreased to 0.8 meter per second. So similarly, we when we increases the load from 200 to 400, the speed of the motor decreased due to the load. And on average, we said that the speed of our robot is 0.4 second, because we put bucket over it, and almost its weight is up to 3 kgs. So the average speed of our robot is 0.4 second, with battery weight of battery and weight of pesticide spread. And apart from that, our robot can sustain 2 kg more to move in the fields. If we increase the weight from 5 kgs, it will be stopped. So here is the final testing of our robot, that our aim was to move in irregular surface, so that we put some hurdles in front of this to move the robots. And you are seeing that it is spraying pesticide and can be controlled through the robot application. You are seeing that this is the rotation of servo motor, and this is spraying the robot. You can control through the Android application. So here is the safety of robot. Initially, we are using components that are placed over the battery, bottom of the robot. So for the safety of robot, what we do, we place all the components in a box. The robot that is designed has pesticide covered in the bucket. So we cover the bucket, cover the pesticide, and the components are placed in the box so that the short circuit from pesticide can be prevented. We put in all the components in a box, and the robot is reliable and safe to use in agriculture for pesticide spray. So here is some calculation of our power consumption of robot. So we are using some components. Here are listed components, that we are using 12 volt DC pump, gear motors, servo motor, relay, FTDI program, ESP32 cam, ESP32 microcontroller, and its total power consumption. So here is the power consumption of each component, and the total power consumption by our robot is 16.98 watt. So after calculating this power consumption, and the battery weight that we are using is 12 volt 5 ampere hour. So after calculation, we get that our robot can be used 3.53 hours. So we are not fully utilize our battery. We are utilized up to 50%. So from that calculation, we get that our robot can be used in fields for up to 1.675 hours. From that timing, we get that how long we can use this robot, and how much distance it will cover. So for that calculation, we also discussed that the speed of the robot on load is 0.4 meter per second. And here we find that the battery can be used for 1.675 hours. From that, we can say that the robot on load speed will be 1.44 kilometer per hour. It means the robot can cover distance of 2.412 kilometer in a single charge. So this is the distance calculation of our robot, that can be cover the distance of 2.412 kilometer in the field area. So our future plans, that according to the report generated by the World Health Organization, that state that approximately 2 lakh people die and nearly 3 lakh people get poisoned with the use of manually spraying pesticide. So our robotic technology will eliminate or will reduce the intervention and brought the death rate to zero. And our technology will minimize the waste of pesticide that is spread in the air or surrounding by the development of low cost robot, and to reduce the loss of agriculture due to the insects, worms, and bacteria by providing proper pesticide through the robot. So these are the references that we used throughout our project. We get help from these papers.